In this example, we have an application problem that states the length of a rectangle is 2 inches less than 3 times the width. The area of the rectangle is 8 square inches. Find the width and length of the rectangle. Use the formula A equals L times W. In application problems dealing with geometric figures, I normally draw a sketch of the figure. Well, I'm talking about a rectangle, so this is about as good as a rectangle I can sketch. And I know the area of the rectangle is 8 square inches. And here's my length and here's my width. So I know the area is length times width. Right now I have 3 variables in this equation. I only want one. Well, I know the area is 8, so I know 8 equals. Now I'm either going to have to write the length in terms of the width or the width in terms of the length. So let's look at our first sentence. The length of a rectangle is. That translates to L equals 2 inches less than 3 times the width. Be very, very careful with less than. This is the one that most people mess up on. So if I want 2 inches less than 3 times the width, I have to start with 3 times the width. 3 times the width is going to translate to 3W. That's 3 times W. And 2 inches less than that, I'm going to have to subtract 2. Notice its subtraction order matters. If you'd have written L equals 2 minus 3W, that is totally wrong. So please be careful whenever you see less than. That's the tricky one. Okay, so now I've written the length in terms of the width. In my equation up here, instead of L, I'm going to write 3W minus 2. That's taken the place of my length, so I have to multiply it by the width. Now I only have one variable there, so all I have to do is simplify this. So I'm going to distribute the 3 into the parentheses, so 3W times W is 3W squared, and then W times negative 2 is negative 2W. What type of equation is this? It's degree 2, it's quadratic. We need 0 on one side. I don't have 0, so I'm going to have to subtract 8 from both sides. So now 8 minus 8 is 0 on the left-hand side. That equals 3W squared minus 2W minus 8. Notice these are all unlike terms, can't combine any of them, and we always want to write it in descending order. Now we're going to try and factor it, and I'm running out of room, so I'm going to go to the next slide where I've already put my equation in here. And now we need to factor it. Well, we want to compare it to ax squared plus bx plus c. A is the coefficient of the squared term, so my a is 3. B is the coefficient of the x, or in this case the w, so b is negative 2. And c is my constant term of negative 8. We need to multiply a times c. A is 3, c is negative 8, so it's 3 times negative 8, which is negative 24. So I need to find two numbers that multiply to AC, which is negative 24, and add to B, which is negative 2. Since the two numbers I'm looking for multiply to a negative number, they are opposite in sign. And since they add to a negative, the one with the biggest absolute value has to be the negative number. So I'm going to start with 1 and negative 24. Those multiply to negative 24, but 1 plus a negative 24 adds up to negative 23, which is way away from the number I'm looking for. So I'm going to put it on pause when I finish my table. So you can see 2 and negative 12 didn't work. 3 times negative 8 didn't work, but 4 times negative 6 is negative 24, and 4 plus negative 6 is negative 2. That's the number I'm looking for. Now, since A was 3, these are not my factors. This is what I'm going to rewrite my middle term as. I'm going to write it as 4W minus 6W instead of my negative 2W. So I get 0 equals 3W squared plus 4W minus 6W minus 8. All I'm doing is replacing this for this. The reason we do this is now we have 4 terms. How do you factor 4 terms? By grouping. So what do the first two have in common? I think the only thing is a W, and it's going to leave me with factor W out of 3W squared is going to leave me with 3W. Factor a W out of plus 4W is going to leave plus 4. Bring down the middle sign. This is subtraction. What do the last two have in common? A 2. Now be careful, I'm factoring out a negative 2. If you factor a negative 2 out of a negative 6W, it's going to leave positive 3W. Factor a negative 2 out of a negative 8, it's going to leave a positive 4. Check your signs. A negative times a positive will give me that negative. A negative times a positive gives me that negative. Now, this binomial is the same as this. That's my common binomial factor of 3W plus 4. So I write that in front. And now what goes in my second parentheses? What have I left behind? W minus 2. So I've now factored it. I have 2 factors multiplied together equals 0. You set each of them equal to 0. So I get 3W plus 4 equals 0. W minus 2 equals 0. So the first one, you subtract 4 from both sides. 3W equals negative 4. Divide both sides by 3. You get W equals negative 4/3. Remember, W represents the width of the rectangle. Can you have a width of a rectangle that's negative 4/3 of an inch? No, that does not make sense. So that is not a solution. And our second factor, W minus 2 equals 0. Add 2 to both sides, you get W equals 2. That's a valid solution, inches. Now, is that all we're asked to find? We need to find the width and the length. So the length on our other slide, remember length was 3W minus 2. And so the length is 3 times W, which is 2 minus 2. Sorry, I'm running out of room. 3 times 2 is 6. 6 minus 2 is 4 inches. So the width is 2 inches and the length is 4 inches. So that is the solution to this application problem.